Welcome to the Voices of Longevity, a short-form interview series from the Institute for Successful Longevity here at Florida State University. I'm your host, Victoria Valko, ISL's Outreach Assistant, and in each episode we speak with ISL faculty affiliates to learn more about their work, perspectives, and background. Joining us today is Dr. Neil Charness for our third episode in Season 2. Dr. Charness is the founding director of Florida State University's Institute for Successful Longevity, William G. Chase Professor of Psychology, and FSU Distinguished Research Professor. His career has focused on advancing interdisciplinary aging research, particularly in the intersection of aging, technology use, and safety. Funded by the NIH, NIA, and U.S. Department of Transportation, his work has significantly improved understanding of health, work, performance, and mobility among older adults. Through his leadership, research, community outreach, Dr. Charness has made a lasting impact on the field of aging and the ISL community. Welcome, and let's get started.
Thank you, Victoria.
So you began your academic career studying psychology at McGill University and Carnegie Mellon at a time when cognitive science and aging research were still emerging fields. Looking back, what originally drew you to studying cognition, expertise, and aging?
Well, that's an interesting question. I started in psychology a little bit late because I started initially at McGill University in the sciences. Found out after my first year I didn't really like them as much as I kind of thought I would. And so shifted to more arts programs and took psychology, philosophy, sociology, English, Shakespeare course, and a French course for my second year. And of those disciplines, the one that interested me the most was psychology, which was more scientific. So it kind of fit with my early interest in the sciences, particularly today we'd call them the hard sciences. Not so sure they're as hard as the softer social sciences, but that got me into psychology. And so I got in a little bit late and found myself in the honors program in my fourth year, rather than much, much earlier, as most undergraduates took psychology. And at that point in time, I had joined up with a professor to do an honors thesis project, Al Bregman. And he was advising me about graduate schools. And he suggested, given my interest in cognition, because I'd never had an undergraduate cognitive course. I'd had other courses within psychology. Cognitive psychology was kind of an emerging field at that point in time. But he caught my attention by mentioning graduate work at Carnegie Mellon University in the States. I was in Canada at McGill. And he had mentioned that they were doing some really interesting work on chess. And that piqued my interest immediately, simply because I was a chess player at the time. I was involved with the McGill Chess Club. And I said, wow, that could be really interesting, doing work on chess skill. So I went to, I accepted their invitation to the graduate program there. And when I got there, I was teamed up with a very new assistant professor who was doing work on, it was called hot cognition at that point, Abelson's lab at Yale, working on kind of emotion and social psychology. And I wasn't very interested in that. He wasn't very interested in the research I was doing on pattern recognition. And so in my second year, I switched advisors to Bill Chase. And Bill, at that time, was starting to take up again work on expertise in chess with Herb Simon, and a very famous research program, the Chase and Simon work on expertise in chess. And so I joined that. I did my doctoral dissertation on that topic, and very quickly realized that chess could be kind of a Drosophila, fruit fly sort of experimental organism to look at cognition. And so that was my entry into the cognitive side of things. When I took my very first position, so I left after my fifth year there to take a position at a small liberal arts college or liberal arts university rather, called Wilfrid Laurier University. This was in Waterloo, Ontario, Canada. And at that point in time, I had done my doctoral dissertation trying to understand the mechanisms behind expertise in chess. And we learned a lot of really interesting things in that particular research project. Clearly the importance of pattern recognition for being able to minimize the search tree that you had to look through to find a good move to play in chess, but also the importance of kind of a large knowledge base to be able to, again, restrict the space, the problem space that you searched in to make it manageable. Because humans couldn't search at a very high rate, maybe a move per second. They couldn't search only a very small portion of that space. And so we were trying to get a sense of the mechanisms. And memory quickly became kind of a touch point for understanding skill in chess phenomena, like the ability of a strong chess player, like a master, to look at a chess position, an unfamiliar one, for maybe 5 seconds and reproduce maybe 20 or 30 pieces from a 5-second glance at the position. But it wasn't as though they had phenomenal memory. Rather, the memory was very specific to the patterns in that game. So if you used random patterns and put them on the chessboard, they were no better than a non-chess player or a novice player. And so memory became kind of a key point for understanding skill. When I got to Wilfrid Laurier University, I decided what I wanted to do was generalize from just chess to other domains. And that got me involved with bridge, which was another hobby of mine, playing bridge, which is a card game. And unlike what I did when I was a graduate student at Carnegie Mellon, where we selected undergraduate students as our test participants, I picked people in the community who were bridge players. Some of them were younger, some of them were older, and I gave them a bunch of typical tasks, generalizing from the chess domain, to look at memory for a briefly seen bridge hand, problem solving on bridge hands, problem solving on bidding, which is an important first phase when you play bridge, and looked at the data, and lo and behold, to my surprise, maybe I shouldn't have been so surprised, but I never had a course in developmental psychology, either at the undergraduate level, had one at the graduate level. It only went up to infancy. And I looked at the data and found, lo and behold, that in the bridge players that I'd selected, among the younger players, they were performing extremely well, depending on their skill level, at problem solving, at bridge bidding, and particularly at the memory tasks we used to try to track skill mechanisms. But the older players were doing as well as you would expect given their skill level, but they were doing terribly on some memory tasks. I said to myself, does anybody know that as you get older, your memory gets worse? That's how naive I was back then. And that led me into the field of aging. I'd never done any work in aging, but the real question I was trying to deal with was, I guess, what we can call the age-skill trade-off. How could older adults be such skilled players despite the fact they had failing memory systems? And that kind of occupied me for the first roughly 20 years of my career, or 15, I would say, 15 to 20 years of my career, which is, what are the mechanisms that enable people as they age to continue to perform at high levels? I mean, if you look at government, you look at industry, there are a lot of people who are of older ages who clearly have diminished psychological mechanisms. Abilities change with age. We can talk about fluid abilities, such as your ability to solve new problems. That declines from the 20s. Other things tend to go up with age. Knowledge tends to rise with age. So you have this sort of age-skill trade-off. Knowledge plays a role in that. And I was trying to understand exactly how those two factors trade off to produce good performance and sometimes expert performance on the part of older adults. So that's kind of what got me, I guess, started off.
So your research spans cognition, human factors, and technology design for older adults. If you had to describe the central question that ties your work together, what would you say it is?
I'd say it's really how cognition, perception, psychomotor performance change normatively across the lifespan. And further, what are the implications of those changes for your ability to design tools and processes, training, to accommodate those changes. So we've moved from the early phases of gerontology, which is a relatively new discipline, not very old, from just figuring out what goes wrong as we get older, or I should add, it's some of the things that go right as well as what goes wrong, to how do we intervene to try to mitigate some of the negative changes, particularly in cognition, which is the field I was trained in first.
So you were a principal investigator with CREATE for over 2 decades, helping shape how technologies are designed for older adults. What are some of the biggest mistakes you see when technologies are designed without older adults in mind?
Well, I think you have to look at the context of design and designers. So some years ago, Wally Boot and I wrote a review paper on aging technology in a journal where we looked at what the average age was of an industrial designer. And it was, if you look in terms of the population of professions, it was one of the youngest ones. And so if you look at how people typically go about design, if they aren't trained specifically on designing for aging adults, they often rely on their own intuitions. If you're a 35-year-old, you don't have many intuitions about the aging process, how it changes visual processes, for instance. Typically in your 40s, a lot of us move into corrective eyewear, contact lenses or glasses, to accommodate to the changes in vision, a phenomenon known as presbyopia, the aging of the eye. It makes it very difficult to focus on near materials. And that's kind of the first sign to a lot of us that we're undergoing aging, when we look at our newspaper and we have to hold it further and further out from us to be able to see the image, the text in it, and focus on it so it's clear. And so once we get into lenses for near vision, that's kind of a signal, hey, I guess I'm aging. There are other changes as well. They're a little less noticeable. That's kind of our first one. So if you're a younger adult and you haven't experienced those types of changes, your intuitions might not be good about, for instance, this is kind of a classic finding in the field of design, that you need larger print sizes to help older adults, particularly those who are undergoing negative changes from not just focus points in vision, but cataract, for instance, which tends to arise in your 70s and your 80s, sometimes earlier than that, your 60s, which is just going to make it much more difficult to focus on anything, small detail. Makes it much more difficult. And so you often will make a mistake and you'll print out materials, say it might be instructional materials about your device in very small print because you're trying to cram as much information as you can in a small space to satisfy the people who are looking at the cost of the technology. They're trying to minimize the costs, and training, unfortunately, and technical support are one of the costs that they're always trying to minimize. That can lead to making things a little more difficult. So that's kind of one example. Let me give you a second for hearing. So there are normative changes in hearing as well. In fact, they typically take place a little later, more like the 50s for males, a little later for females. Whereas for vision, it's pretty close. Those changes are not just in the intensity of the sound that you're going to perceive as your aging apparatus starts changing in negative ways, but also in more subtle processes like localization. What do I mean by localization? This is the ability, when you hear a sound source, to be able to localize it in space. So if someone talks to me, say I'm talking to you, and the director of ISL tries to get my attention by saying something, I won't look this way, I'll look in his direction because I've localized where the sound is coming from. So you may have had this phenomenon. You're, say, in your kitchen, and you hear a beeping sound. And it's sort of often those beeping sounds are put at a high pitch because the cost of the little diaphragm that they have to use to get the beep out, or the mechanism for that, is often higher for being able to get middle level sounds or low level sounds compared with high pitched ones. It's just cheaper to do it that way. And you can embed those things cheaply in mechanisms like electronic devices. And what you're hearing might be a beep for a low battery warning on a device. And you're looking all around the kitchen because it's a very high frequency. You lose high frequencies more quickly than low frequencies as you age. Your sensitivity drops much more greatly there. In fact, if you look at something, typically we hear between 20 and 20,000 hertz. And high hearing is most sensitive, or remains more sensitive, in the lower frequencies for older adults than in the higher frequencies. So if you put a high-pitched beeping device, I'm going to sit wandering around my kitchen trying to localize it, particularly if it beeps infrequently. If it's at a longer duration, I'll have a better chance of turning my head and being able to pick up its location. So that's kind of like another example for hearing. More importantly, for things like changes in memory, we have limited capacity working memory. And what that means is our ability to maintain information, listen to it, store it, and then be able to recall it by outputting it in some way, that diminishes fairly strikingly as we get older. And I'll give you an example. So today, a lot of our interactions with computer websites and computer products is through multi-factor authentication. Like here at FSU, if you go to log into your account, you don't just sign in and give a password, you also have to respond to a challenge, which is a second factor. It could be your phone or something of that sort. Early on, the second challenge was often sent in the form of a relatively long string of numbers or letters. And you had to type those in, plus often there was a cutoff for the amount of time you needed to type those in. The other major change, is probably the biggest change with age, is slowing in the rate of information processing. And so I've seen this happen. I was watching my wife as she was signing up for Social Security. Challenge came back. They don't understand she hasn't got fast typing skills, so she can't type quickly. She's looking at, she got the thing on her phone, or maybe it's on the computer through an email. Maybe she isn't fast at copying and pasting, so she can get the whole thing and paste it in. And it times out before she can put it in. She has to start all over again. And so that's an example of designers not understanding that there's slowing in the rate of information processing, the rate at which you can type, or the rate at which you can pull in a password and then reproduce it by typing it if you haven't got strong typing skills. And that's another good example of bad design, not taking into account the normative changes, in this case in memory, that take place, or in speed of processing, typing speed perhaps, and disadvantaging an older user of your particular technology. So failure to understand that and people's limited troubleshooting capabilities. Often they're living alone, they haven't got someone to immediately help them, to troubleshoot the problem. Those are, I think, good examples of where designers, if they trust their own intuitions and don't learn about, the first commandment for the field of human factors, which I moved into in kind of mid-career life, is know thy user. That's the first commandment. And a lot of designers, young designers, don't know their older users. Now, I've been working at that for years and years. I've been invited to give a section on, aging and inclusive design is usually the title, at the University of Michigan for their very long-standing human factors short course. It takes place every summer. And I've been there for about 20 years, giving this segment as part of the large segment to train people on human factors and design. And so I'm trying, And my colleagues in the CREATE program, our center, our Program Project Grant Center, have been together for 25 years. We've been publishing books on this and so on. But it's a long process to familiarize the design community with the normative changes and how to do better design. Long-winded answer, but yeah, there's an answer to that question.
Absolutely. You played a major role in building the Institute for Successful Longevity here at FSU, from shaping its mission to expanding interdisciplinary collaboration across campus. Why is it important to you that the ISL brings together psychologists, engineers, public health researchers, clinicians, and policymakers?
I think it's really a good example of how big problems really need big teams to tackle them. And aging, I think, is probably the quintessential discipline or problem area, challenge area for interdisciplinary research. And take as an example dementia as a problem area that a fair number, perhaps 20% of aging adults, will face if they live long enough. And that requires things like disciplines like biology to look at what are the cellular mechanisms, what's disrupting the brain in this case, from being able to process information efficiently. It requires psychologists on measurement. Can we detect early signs of dementia, perhaps intervene earlier? Clinicians to provide the diagnosis, the interventions. People like social workers who help out, for instance, with the caregivers of people who are trying to cope with dementia in a loved one. Sociologists, political scientists who can help drive the policy change necessary to get society to allocate adequate resources to solving that challenge. Engineers to design the assistive devices that the families and the people living with dementia may need to help them to function, perform more effectively. In other words, there are a tremendous number of people who have a small piece of the puzzle that they've already got perhaps potential solutions for from their discipline. If you can bring them together in a team, either as a research team or as a design team, that can result in, I think, much better progress in meeting those types of very strong challenges.
You've also witnessed enormous changes in the aging research, technology, and higher education over your career. What do you think are the most important unanswered questions about aging and longevity today?
I still think it's mainly issues in understanding the mechanisms underlying the sorts of changes, both normative and non-normative with diseases, that take place as we age. And so we've made great strides in being able to describe the nature of changes. We haven't made as great strides, I think, in understanding the mechanisms that drive those changes and getting at basic processes that we can intervene more successfully on. There are a lot of people who devoted an enormous amount of time looking for what I would call biomarkers or risk factors, and that can be an endless loop. Here's a risk factor for dementia, here's another one. There are probably 100, and if we keep on working, we'll find even more. But what that should really be driving is what I would say is experimental research, intervention research, to really try to validate and build better theories and models of those changes in aging. And so for me, still working somewhat actively in the field as a part-time scientist, trying to understand the challenges, try to understand the mechanisms that drive the changes that result in those challenges. Those are the things that I think we have to do a better job with.
For students and early career researchers who are interested in aging, cognition, or technology but aren't sure where they fit, what advice would you give them as they're starting out?
I think the secret to being successful in a complex and multifaceted field like aging is curiosity. You need to be curious for a couple of reasons. One of them is you need to find a good practical problem that people have. We have a very good database here at ISL, the registry, lots of people eager to help you with whatever problems you're interested in working on. That curiosity has to be there to drive you, to keep your motivation going, for you to acquire all the tools that are necessary to really have an impact on a challenge or a problem that you're trying to solve. So I'd say curiosity is important. Learning a little bit about different disciplines, particularly if you want to work in interdisciplinary teams. It turns out that the terminology is different from discipline to discipline. They have the same word may mean something very different across disciplines. Similarly, different words may actually be pointing to the same concept. So you need to be curious about other disciplines. I think you need to do some reading outside of your own area. Clearly, while you're working on a dissertation, you have to become the expert in that relatively narrow space. But later on, particularly if you're fortunate enough to be tenured in a university, you have the opportunity to broaden your horizons. Go out to lectures, brown bags by people who are not necessarily working in your field, your area. Even if you think it isn't relevant, they may have an insight that will help you approach things differently within your discipline. And they can be important team members when you're applying for funding to try to tackle that big problem that you really hope to solve. So I'd say be curious, be open, and try to do some reading outside your discipline.
Thank you, Dr. Charness. And that wraps up our episode of Voices of Longevity. A big thank you to Dr. Neil Charness for sharing your insights and experience with us. If you'd like to learn more about the ISL and the research happening across our network, please visit isl.fsu.edu. I'm Victoria Valko. Thank you for listening, and we'll see you next time on Voices of Longevity.
Thank you.